Okay, it's simple as this. This is Roger, Mudfossil University. Is light a particle or a wave? Well, guess what? Sound is a wave. We know that. Boom, and it makes a wave. But it will not go through a vacuum. All right, so the speed of sound in a vacuum is zero. It doesn't go anywhere. It cannot travel in a vacuum. Why? There is no particles in that vacuum to bang into and push the other particles. They can't move. There's no interaction. Well, guess what? Light goes through a vacuum. You have a vacuum jar there, and you shine light through here. You pick up light on the other side. Not a big problem. So what does go through a vacuum? Light. So, is light a particle, or is it a wave? Well, it's obviously not a wave, because a wave has to have particles to bang through. It's a particle that goes right through there, and that particle is so small that it interacts with virtually nothing. Because almost all the particles in space are congealed into these blocks. And then they have little bits and pieces floating around them out there. They call them orbital electrons. But the block in the center is so tiny, we don't realize. We think it's big, a big block. And no, absolutely not. There's almost nothing in an atom. So what happens? Light comes, pew, 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 pew. It might hit there, and when it does, you get a little concussion, you get a little glow. But it just keeps going. It'll keep up, and sooner or later it hits enough stuff, it stops. No magic here. All right, I'm starting you off with this so you understand where we're going. This is serious. This is accelerated light. That is total white Cherenkov radiation. There appears to be no positiveness in this. Those dark spots are positive particles. These were white, these were dark, they came through as up and down dipoles, they got separated in here, somehow the blacks got shifted out all the way around. See the little dots of blacks? Dot, 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 dot. Somehow they got pushed out, the whites got through. Those, to me, that's energy. The dark is anti-energy, or it's lack of energy, I don't know. But anyway, they were once attached, now they have become separated in my world, and now they're coming back to attachment, and then they settle down. All right, now let's go through some, I got a lot of stuff to show you. I've had a lot of people asking me for a lot of, show me some more, show me some more. Well, I'm going to show you some more. Okay, again, I do, all the pictures basically I'm showing, I have some from other people, but basically it's all from Rod, and these are, we worked a very long time at this, and I selected the most magnificent ones, and they are magnificent. And this is red pulse laser light. This shows that all of the particles in the region get a little bit excited, and they just happen to take on a glow. I don't know how Rod did. I have the same stuff he has, but I couldn't get the same results. He's just a fabulous guy at doing this. Now, what are we seeing here? This was that same red laser pulse, but now you see the particle pulling away from its source. It's getting accelerated, and why? Because of the venturi. And the venturi is two round drums, just like that, of steel. And the light hits in there, and it crushes into each other's regions, just creates absolute chaos. That is extreme, unbelievable energy, because they are forcing each other to almost combine. This is plasma. Plasma means that the particles are in a state of chaos, that they are disassociated from each other. All right, that's plasma. They disassociate from, and I can show you this. And then when they come back together out the other side, they recombine and they create these patterns, because this is a single slit. So that's not interference with flappy waves from two slits. This is interference from repulsion, and it's magnetic repulsion of the particles. They set up these patterns because that's a spinning particle. It's a spin. Some spin under, some spin over. They go this way, they go under, they go that way. They come over the top, they go this way. I have all the evidence. I could prove every single word I'm saying. And you could see the particle, I hope you can see it, And you can see what's coming out here, which they call the interference paths, not interference. So let's go forward. Oh, by the way, you see these, all these little white dots. These are also free electrons that are in the air. Normally, they're going to be attached to water molecules and molecules that like to have extra electrons attached to them. But if it gets dry, they will find a source that is more attractive, and that will probably be you. And then you will touch ground, and it'll snap just like that, because those leave your body to go to a more attractive source. That's static. This one just blows me away. Phew, coming at us with vengeance. These are the Higgs. Every one of these white spits is a spinning, highly compacted, spinning magnetic particle. And as it spins, the particle is only there. That's the particle. That's the particle. That's right there. That's the particle. That's the particle. As it comes through, it leaves a wake behind it of magnetically polarized particles, like a spinning pinwheel firecracker. Think of it that way. Shh, coming through space. Look at it, it's pointed. I don't know how he got this stuff. He's just absolute artist. I mean, unbelievable. This is not CGI. This is right out of the accelerator. And this is a crushed particle. Both sides are crushed. That's why it's higher energy. It came all from the red source. So I think I pretty much understand what happens. Now, that blue one, though, is going to come back to a red one. See? It turned to purple. Now it's going to, can you see that? Yeah. It's going to come back to the same color as all the rest of them. So this gives me some kind of a feeling that the particle is a little different than a blue particle. Because you can see, we have green, I can show you that too. The greens come through, they don't change back to red, they stay green. So why? Is it just spinning faster? Or is it a bigger particle? Or is it going faster? And I have all these shots I can show you, red interacting with green and all this stuff. So let's just keep going. Let's see what else we got here. This is all rod stuff. This is chaos right at the slit. Not much to see here, but you can see they're all particulate. Then they come back to a less energetic, and then they come back to their reds. It seems they come back to whatever they started as. So, and like this is a shower. That's a reverse spinning particle, and that I think is antimatter, and that did something really strange. Here's another one of these interactions where you have a different, and that's being squished. All right, what do we got next here? All right, this was one from Jay Hosking. He's doing some work too, and this is I'm not sure. It looks like a little light trumpet. I'm not sure how he did this, but we have here's rods. This is fabulous. I think that was that white particle. I'm almost 100% sure of it. That I said was spinning in reverse, anti-particle. It's starting to create its own field. So it changed from this state to this state, or it's changing. This is what happened. I can see some of this is continuing on to do this, and some of this is going on to do that. That's why they say that there's a differentiation in the lepton quantities, and that's why they've decided that the model is totally wrong because of this stuff. And I don't even think they have any idea about this yet. Nobody's paid a bit of attention to what I've showed, and it's pretty damn impressive in my world. You know, show me that over at CERN. They can't see this. This is light. This is light. What they're doing is they're taking bombs and smashing them together, and then they got pieces going everywhere, and then they dig through them and see if they can find anything like that, and they can't. I don't think they've ever found anything this good. So that could be bragging, but if it's true, it ain't bragging. I've shown these things over and over and over. I know people are getting sick of seeing them, but I'm just going to keep showing them until somebody pays attention. Now that's spinning light. I don't care. You'd have to be an idiot not to understand that. This is a single slit. The slit is up here. It's coming through and it's spinning down there. And some spin off to the right and some spin off to the left. Over is to the right, under is to the left. He's got it twisted just a hair to this side. You see the more concentration there than over here. So, anyway. let's go to the next thing. It spins. Let's just go with that. These are different wave functions. We see them all. This is the blue. That's the particle. It's spinning to the right. That means you will see it drift to the left in the sequence. It's collapsing up here. It's expanded here. Obviously, it's slowing down. These are those fields that surround the particle as it goes. I said this particle's in the center. There it is. These are the fields. They surround it, so you don't see the actual particles out here. You see the particles' influence on the other particles just like this that are sitting out here. All right, now let's see what else we got here. All right, these are the red electrons. All right, now this is the accelerator. These are all jumbled up together. They come out, they do this, and then they turn into this. All right? It looks like a torus to me, but I can tell you one thing for sure. Wait do you see? These can separate. This is the charge separation, and they think it's some kind of spooky, entangled this or that, but it's not. It's just, and Einstein had it right, and I don't really normally go with him a lot, to be honest. Now, this is what Harvard did. They did pretty much the same stuff as us, but I don't think they knew what they were doing. They were looking for some kind of graphene energy filter. I don't know. Gaetan. I have no idea what they were doing. Blue wave. What do we got here? Oh yeah, that's through light, through glass. You see this? That's a bulge. It's through, there's certain, I'm pretty sure it's through glass. Again, Rod took these pictures, and he was just fabulous. A lot of them I fully understand. Some of them, there's just so many of them. I mean, you can only do so much. This was green, coming out. There's the particle declining in energy, and all of the things around it, just follow it. And these are exactly what you see over in Ireland and all this. I have some friends over there in Ireland, Marguerite, and she loves this stuff because, they were doing this stuff early. And we still don't understand it. Electron over proton. Oh, they're showing how a proton, I don't know. That's not my stuff. Sound bubble. This I can go with. An electron is going to control a sphere around it. Now, I don't know whether these electrons are more and more energetic, so they have more and more of a sphere and more energy shells, let's call it that way. Just like an atom, they say they have their electron orbital shells. Well, to me, I'm going with an electron itself. Follows the atomic model of valence shells, and I got a feeling that the greens and the reds and the blues are different number of shells in here. And they bounce, because that's my theory now, is electron bounce, which is the energy, and electron flood, which means the nature of the cosmos. It's flooded with these, flooded, and that's all there is. That's all there is. But they're magnetic and they attract together, but they're still reactive. So they can do a lot of things. They can attach, they can detach, they can create energy, they can create. The cold means they're leaving; they're just going away. Hot means they're forcing themselves into everybody else's regions. It's push to shove. And the more electrons that smash into our atmosphere, the more we get overloaded. They don't just bounce away and go into space. They want to come to Earth because Earth is an attractive source, is spinning with its magnetic field in through this magnetic soup, creating literally a generator effect. It's nothing more than we are as a generator. And that generator creates a magnetic field that circles our Earth. It's called the magnetosphere. And that magnetosphere repels, it tries to push away particles. We can't push them all away. Can't push them all away. They're coming in copious. Well, they hit you in the face, you know that. Get a sunburn. They're filling up our atmosphere and they're not going to go away. So if they think they're going to cut down on CO2 and everything's going to be fine, that's just fantasy. Absolute fantasy. In my opinion, but that's just me. Alright, this is the other one here. This is the green. Now, that looks identical to the red to me. So, I'm seeing 4 particles again. Is it only 4? Looks like that to me. Are these bigger than the reds? Are they more energetic? Are they just spinning faster? Are they going faster? I have 100% opposition to everything that I've ever been told about physics at this point. So if they say, oh, they have to go the same speed, no, absolutely not. I can see they accelerate, no question whatsoever. I can see. Well, let's look at it. Okay, there they are in a trail, the green electrons. This is just light from stars. You can see has a similar radiation. This is my friend Renz over there in France. These are Higgs fields that are tumbling off his finger. That's his thumb. And these are leptons. This is blue, green, red, blue, green, red. And it splays out. That's what they say. And then the 3 of them together make white. You're seeing it. This is sunlight. This is full spectrum light. And it's a half of a venturi. So what are we seeing? We're seeing a full spectrum Higgs. And we're seeing the venturi effect over here, splitting the light up. That's what I'm seeing. So everybody else is working with lasers. Now Renz is doing he's doing finger science. Anyway, and well, you can see he's got it. I mean, it's just unbelievable what you can do with almost nothing. That's just that. Now, these are light particles out in space. What these are is they are electrons being bombarded in our ionosphere and so forth. These are light carved, light symbols. The ancients knew this stuff. I mean, there's not much difference at all to what I've been showing. And the spiral galaxy. We're on an arm of the Milky Way, being swirled around through soup. This soup. Now, what happens if we hit a dense soup? What if we overlap one of these? I mean, who knows what's going on? I don't know. What do we got there? Oh yeah, Cherenkov. Like, this is pretty obvious. It's what we are showing is the electron and neutrino electron shower. High voltage electron, the accelerated electron. I see no way you can dispute that. It crashes, no way to dispute that. It creates different sets of these fields. No way to dispute that. Cherenkov radiation is an extremely white, energetic, high energy, accelerated particle. What do we got here? That's just all of them together in one shot. This one here. See, there they are, spinning all independent of each other, just regular light. What do we got here? All right, these are particle fields. Surrounding the fields is some free particles that are just laying around there, lightly attached. This is Fabian stuff here. All right, that's a particle interacting with fields. So I don't know how. I think he shot 2 lasers through at the same time. One of them was a little closer than the other. I don't know. He did something a little strange there. He does some strange stuff. Oh, hold on. He had a experiment on the space shuttle, I guess. I'm not sure what it was. This is light coming through space to us, photographed with. I don't know how they did it, to be totally honest with you. I'm not doing a lot of these. Well, I'm doing literally none of these experiments. I did them. I have all the stuff. I've shown it over and over. I'm just not good at it. I got a lot of people that are doing it. I don't have to. Why should I bother? All right, here's the Higgs. Here they are all over. Why are they out there, Roger? Well, they're out there because they're interacting with the water molecules. Water molecules are the things that stop this kind of radiation. And this is what they're going to be flooding through our atmosphere with 5G, I think. I don't know. You might even be able to see these if you were real tricky about looking for them. But you see what these are Higgs fields. They are there because of a slam into water molecules, which is the water vapor. That's how I'm seeing it. Now, this is the one. This is the killer. This is the one Rod blew my mind out. And this is the one that is charge separation. And this is why I'm going to go with Einstein on this. Because he said spooky and tangled from a distance, impossible. I say it is also impossible. Well, I can't say it's impossible, but I'd sure as hell like to see how they do it. Well, the way they explain the experiment, it's just nonsense to me. What do I see here? Well, you saw those four particles. There was a black and a white and a black and a white. Boom. Or red and a black, whatever. So we know they're coming this way. And then when they get to here, there's absolute pristine whiteness here. However, if you look carefully, you'll see all these little black dots. And they're dots. They are actual little dots. You see that? Dot, 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 dot. Now, what are they doing? What has happened? The only thing you can take away from this is that there are two different charges, a dark and a white. I don't care how your mind works. They're opposite something. And so let's go opposite charges. Now, we know this is a venturi. And we know it's set up like this, where all these particles have to force their way through this venturi. So what happens then? They have to invade each other's domains. They want these domains. They say, stay away from me, just like a ball. And when you crush them together, you can make them almost flat as a pancake. You can make them just hard if you push them so tight. And then what would they do? And that's what they did. Now, why is it only white here? This is the thing that's killing me, because I still can't understand this. I need help with this. If somebody can help me, I'll love it. Because I'm seeing white here, and I'm seeing like these guys are walking around the edges and coming, trying to get back into here, or they're pulling these out of some other region. These black things, and in this region they are the black and white together, but you don't see it. Now, I don't know. I just don't know, but I'm seeing a reconnection to white to black here. That's what I'm seeing, and over here too, as they come off of here, everywhere. And they back out of here black too, black dots. It's just, it's exciting to see this, because I have no idea what it is. But if they're talking about spooky and tangled from a distance, this is spooky and tangled right up close and personal, as far as I'm concerned. So at the distance, I have no idea how they decided they could interact these things instantaneously from around the world, and then they sort of notice something happened. You're going to have to show me a little more on that one. Now, these are the ancients. They knew all this stuff. They knew all about rainbows and angles of light, and I mean, I'm serious. They knew more than our scientists do now. I'm not kidding. I know it's just. Here's Wrens in black and white, showing what's coming through. It's pretty obvious. There's an interaction. Here's some rainbow Higgs smashing into particles. Here's a little more carved symbols, very obvious. All right, this is really interesting. This kid is giving off Higgs fields out of his mind. I don't know what to think about that one. I don't know what to think. I have no idea where that came from. Cloud chamber passing. That's Higgs fields, and that's just, these are called Van de Graaff generators. They generate a shoot, and there's a vapor of alcohol, usually something like that. And when the electrons pass through it, they illuminate it and they vaporize it and they make the fields. Exactly what you expect if what I'm saying is right, and obviously it is. There it is. That's exactly it. Exactly what it is. Cloud chamber blasted with electrons. Oh yeah. So if J. Hoskins sent me this, E equals MC squared electron flood. That's me. What else we got? Okay, now this is Fabian again. I think I showed you some of the other stuff already. But anyway, here he is, going red on green. Now that's interesting. And you see a green doesn't crash until way out here, and a red way here. And I think I talked about this before. I don't know whether it's heavier or lighter or spinning faster or spinning slower. The red is supposed to be a much longer frequency, and the green is supposed to be a shorter frequency, means it spins faster. Is it going out here faster, or is it just spinning faster? I would think if it was spinning faster, you would see it illuminate way back here, because the angular momentum would make it interact with the particles there. Although maybe it's because it's accelerated. It doesn't show up until it can slow down to interact, and it gets more accelerated because it's more energetic. I mean, there's a million ways you can go in your mind here. I mean, my mind's gone all of them. And then you see this? That's some kind of dual interference. And they talk about that. It's like a re-resonance, some wacky thing like that. And here he is. This is all green particles. See that? This is green laser. And there's that wave again. There's that strange looking pattern, only with green this time. So I don't know what that is, to be perfectly honest. But here's all those little positive, negative particles. They're back-to-back dipoles. That's the only way you can look at that. No other way. Now this is the stuff Rod was doing. He was looking for things in the life, symbols of life. Let me put it that way. And he's found stuff that just make you cringe. All right, now here's the Higgs fields, and this is what CERN does: is they smash huge things together, like gigantic buildings, and they just grow into a million pieces. Then they look for these little bits down here, little tiny bits. That's all we have is these little tiny bits, so we don't have to do all that stuff. What do we got? There's some more Higgs. They know what it looks like, but all they have is drawings. There's a simulated, yeah, well, we don't have simulations, we have the events. Now what's this? I don't know what this was, to be honest. Let me see, 1, 2, 3, 4, 5, 6, 7, 8. 2, 4, 6, 8, wow. 1, 2, 3, 4, 5, 6, 7, 8. That's the rule of 8. I don't know what it is. That was sent to me by Anthony Cullingworth. Now, look at this. Woohoo! This is Rod. Look at this. What do you see right there? What do you see right there? And what do you see right here? This is what he's looking for, is things that might have life to them. And I don't know. I mean, everything looks like something, but some of this stuff looks like something pretty interesting. You know. I don't know. But Rod deserves his time in the sun. I'm going to tell you that right now, because he did more work than anybody on this. You know, I worked with Rod for a long time, and he's the one that actually did the work. I just looked at the picture, so I don't have I'm not, you know, what I'm getting at is, it was a cooperative effort, but he's the guy that actually did the work, and he is the one that was doing it, looking for this stuff. He wasn't looking for atoms. He wasn't looking for charge separation and entangled, spooky things at a distance. He was looking for this kind of stuff. And that could be a picture of a person. I don't know. They say we will become light. Maybe whoever this was just walking by at this time. I don't know. No idea. But I felt bad because Rod was doing all this work for me, and I was not able to really show his stuff and say these kind of things because, you look at that and you say, where's Jesus and the devil? Well, maybe it is, maybe it isn't. I don't know, but if I go run around saying that, people say you're insane, and of course they say I'm insane anyway about everything. But you keep adding insanity to insanity, then they really put you in a box. So I had to make sure that I had enough evidence to not be in that box. And now we can look at things, and who knows what's there? I don't know. But if you don't look, you don't know. So the first way to become stupid is become too smart to look.